Good morning. Recently, I assigned a worksheet called Drawing Squares, where the challenge was to draw a square given one of the sides. So this video is to give you some hints or tips on how to do that worksheet. You probably think that if the line that's given to you is already horizontal or vertical, it should be pretty easy. Just measure the number of squares or the number of units the line is, and then if the first line given is horizontal, then the next line should be vertical. So since this is 5 units horizontally, the next line to be drawn should also be 5 units, but vertical. So let's start from this point. 1, 2, 3, 4, 5. So there's my third point. And then 1, 2, 3, 4, 5. That'll be my fourth point. And because all the lines are horizontal or vertical, then all the lines must be 90 degrees away from each other. So let's draw these other 3 lines. Here's one. There's the second one. And there's the third one. So this is a square, right? It has 4 equal sides and 4 90-degree angles. Okay, so you might also do that for a vertical line. If you were given a vertical line, then the other lines must be horizontal. It would be just like this. Now let's go for a diagonal line, a perfectly diagonal line, like I have in number 2 over here. So this line is going down and to the right, and it uses 3 squares diagonally to do it. Then this is still not that hard. You might agree that if this line is going down and to the right, then 90 degrees away from it should be going up and to the right. So if this is 3 diagonal squares long, then the other line must be 3 diagonal squares going up and to the right, up and to the right, up and to the right. So my next point should be over here. And from here, we can go up and to the left, up and to the left, up and to the left 3 times, perfectly diagonally, to get my fourth point. And as you can see, if we connect these points with lines, with 3 more lines, we will get another square. But I suspect you're watching this video not for these 2 examples, but for the third example. In this example, this line is not vertical, it's not horizontal, and it's also not perfectly diagonal, right? In order to accomplish drawing a square for this, we'll need to borrow one of the concepts from chapter 3, from a previous chapter in the book. And that is the concept of slope. What is the slope of this line? Well, let's see. The rise of it is 2 down. You have to go 2 down, right? And going to the right, you have to go 5 to the right. So if you start here, go 1, 2, 3, 4, 5. So that gives us a slope of rise over run of -2 over 5. So how are we going to draw a line that's the same length as this and is 90 degrees away from it? My proposal is to draw a line that's 5 over 2, whose slope is 5 over 2. So I want to prove to you that a line with a slope of -2 over 5 is 90 degrees away from a line whose slope is positive 5 over 2. In other words, if you flip the 2 numbers of the fraction, and if you flip the sign from negative to positive, or vice versa, you'll end up with a line that's 90 degrees away from the original. So let's do that by copying this drawing onto another piece of paper. So let's analyze this. So just as before, the slope of this line is -2, which means 2 down, over +5, or 5 to the right. Okay? Now, let's draw another line, just like we said. We want a line where the vertical distance is not 2, but 5. So we're going to flip the two numbers, right? And where the horizontal distance is not 5, but 2. So instead of going 2 down, let's go 5 up. So 1, 2, 3, 4, 5. And instead of going 5 to the right, let's only go 2 to the right. 1, 2. So my next point is right there. Okay, so let's draw that line carefully. And let's equip this line with its own rise and its run. So the run this time is +2, and the rise is +5. Now take a look at these two triangles. After examining it a little bit, you should realize that these two triangles are the same triangle. So this new triangle is a rotated version of this triangle. Let me show you. So here I cut out the same kind of triangle and I fit it over there. If I hold this point with my finger and turn it, I can see that it's exactly equal to the other triangle that we drew, the one where we flipped the numbers, right? So these are just two copies of this same triangle, aren't they? Now, I want you to pay attention to the two blue lines, that I have drawn. So there's one blue line over here that I want you to pay attention to. And here's another blue line that I want you to pay attention to. I want you to notice that this line is vertical and that this line is horizontal. Do you remember? All the horizontal lines and all the vertical lines are 90 degrees apart from each other. So these two are no exception. If you travel from this blue line to this blue line, you will get 90 degrees. Now take a look at the red. Imagine the red lines traveling towards the blue lines. So imagine a motion from this red line towards this blue line. And since we could imagine it for this one, couldn't we also imagine it for this triangle? So from this red line, imagine it traveling to this blue line. Since these two are the same triangle, isn't these two angles the same? These two angles should be equal, right? Therefore, if starting from the two red lines, we get to the two blue lines using the same angles, and the two blue lines form a 90-degree angle, then the two red lines must have started out as being a 90-degree angle from each other as well, right? Because if they were moving in the same speed and the same direction, and they ended up being 90 degrees apart, then the starting point must have been 90 degrees apart as well. So if the blue angle were 90 degrees, then the red angle must also have been 90 degrees. So hopefully I have proved to you that the motion that I gave by flipping the two numbers, the rise and the run, and flipping the sign from negative to positive, gives you a line that's the same length and is 90 degrees away. So how are we actually going to do it for this line? Well, this is what we're going to do. We're going to copy the 2 and the 5, but we're going to switch them. So instead of going 2 down, we're going to go 5 up and 2 to the right. So start here. 1, 2, 3, 4, 5. 1, 2. There's going to be my first point. My next point is going to be the same 5 and 2, but going around in a circle. 1, 2, 3, 4, 5. 1, 2. So here's my next point. So if I draw lines from these two sides to these 2 points, I'm guaranteed a square. Let's check it out. Let's draw the first line. Let's draw the second line. And let's draw the last line. As you can see, we were able to make a square out of this red line. And all these lines are the same length, and all of these angles are 90 degrees. I hope this helps you answer this worksheet. Thank you for watching this video, and may God bless you.